Hello students, and here we are with the class on square and square roots of class 8, and we are going to do some selected NCERT level questions of square and square roots so that it will help you in your half yearly exams as well and all the other exams, right? So I hope you have gone through basic fundamentals of square and square roots, and let's quickly jump over to the questions. Okay, now in the first kind of questions, what we are going to do is we are going to understand the pattern recognition, right? How to understand what is the pattern here. Okay, so this is one question which I liked it really. 1 square plus 2 square plus 2 square is 3 square, and 2 square, 3 square, 6 square is 7 square. So from 2 I move over to 6 by adding 4. Okay, from 6 I move over to 12 by adding 6, right? So from first I added 4, then I added 6. So 6 plus 6 is 12, 12 squares. Then I'll add 8 over here. So it'll be 20 square, right? So it will be 20 square over here. Now, similarly, you are seeing that in the second blank, it is 2 square, 3 square, 4 square, 5 square. And here it will surely be 6 square, right? So then that's why the next term is 7 square. Right now here also, if you see over here, 2 square, then 4 added 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, 20 plus 10 is 30, and 30 plus 12 will be 42. So this will be 42 square. So right, so this term will be 42 square. Now similarly, if you see on the right hand side, again you am adding 4, so 3 plus 4 is 7, that's why 7 square. Then it is 6, so 7 plus 6 is 13, then it is 8, then it is 10, and then it will be 12. So it will be 31 plus 12 is 43, so it will be 43 square. So this is how you understand the patterns, by looking at the set of numbers of squares and then understanding pattern and fill up the blanks. Okay, so this is a very good question which I found out. Okay, now the next question is, write the Pythagorean triplet as one member is 6, then 14, then 16. So we know the Pythagorean triplet is 2m, m square minus 1, and m square plus 1. Okay, so 2m is 6, so m will be equal to 3. So the other triplet will be m square minus 1. So 3 square minus 1 is 7, 8, and 3 square plus 1 is 10. So the other members are 8 and 10. Similarly, 2m is equal to 14. So we are saying that 2m is equal to 14. So m will be equal to 7, right? So m square minus 1 is 7 square minus 1 is the other triplet, and 7 square plus 1 is the third one, the biggest one, or the hypotenuse of that Pythagorean triplet. So 7 square minus 1 is 48, and 7 square plus 1 is 50. So the other triplet, two members are 48 and 50. So here also 2m is equal to 16, so m will be equal to 8. So m square minus 1 is 8 square minus 1 is 63, and m square plus 1, 8 square plus 1 is 65. So the other members are 16, 63, and 65. Okay, so I hope you understood these questions. You just have to remember the Pythagorean triplets are 2m, m square minus 1, and m square plus 1. Now the next question, for each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Now all the questions of this exercise are division multiplication type. So I picked up one question, and it will help you in solving the other questions. So 252, you prime factorize 252. It will be 2 into 3 into 2 into 3 into 7. So if you divide it by 7, because you are finding pairs of 2s and 3s, but 7 is alone. So if you remove this 7, we get a perfect square. So this should be divided by 7. Okay, so if you solve this, if you prime factorize this, it comes out to be how much? It will be, now the last two digits are 25, so it will be definitely divisible by 5. So 5 into 5 into 1, 1, and 7. So it'll be 5 into 5 into, so 17 converted as 3 into 3 into 13. So if we divide, now pairs of 5s and 3s are there, but 13 is alone, so you have to divide it by 13 to get a perfect square. Now again 396, this converted as 2 into 3 into 2 into 3 into 11. Now pairs of 2s and 3s already, but 11 is alone, so you have to divide it by 11 to get a perfect square, because then you will be free of 11. Okay, Again, if you divide it by 5, it becomes 5 into 529. Now 529, if you do the perfect square, it becomes 23 times 23. So 23 pair is there, but 5 is alone. So you have to divide it by 5 to get a perfect square, right? So the answers are 7, 13, 11, and 5. Now, again, this question, find the smallest square number that is divisible by each of the numbers 4, 9, and 10. So what is the LCM of 4, 9, and 10? Okay. What is LCM of 4, 9, 10? You can do it by long method as well. So it'll be 2 times 2, 9, and 10, and 5, sorry. So the LCM is 2 times 2 times 9 times 5, because nothing is common now. Now you're seeing that 2 and 2 can witness 2 square, 9 and can witness 3 square into 5. So pairs of 2s and 3s are there because the power is a even multiple of 2 of is a multiple of 2, sorry, it's a multiple of 2. So which means we need another 5 so that the powers of 5 will be even. So we have to multiply it by 5. So it will be multiplied 5. So this is the first square number. So it will be 36 into 5 is 25. So 36 into 25 is 900 is your answer. So that is divisible by these numbers is 900. Okay, move on to our next question. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Now, some of the questions you can do it by long division, most of them, but some of the questions you can use your basic common sense. Now, you know, 400 is a perfect square of 20 square. So if you to make this number is 400, you can definitely subtract 2 to get 400. Okay, you can do it by long division method as well, which I'll tell you in the next question. Now 1989. So you divide in 1989, take powers. Okay. Now if you do it, 4 times 4 is 16 and 389. 4 plus 4 is 8. Okay. So it will be 84 times 4 is 336. So it will be 53. 53 is getting, so 53 would not have been determined perfect square. So which means if I subtract 53, I get a perfect square number, and that perfect square root is 44. Similarly, in the previous question, the perfect square root is 20. Right? So again, 3250, you take this one. So I'm doing this one, you can try this one yourself. The fourth one, you can try it yourself. Okay. So if you do it, take pairs of 2, 5 5s are 25. Okay. And 7, 50, 5 and 5 is 10. And 107 times 7 is 749. So you subtract 1, you get a perfect square, and the perfect square root is 57. So you subtract 1 from this, and the square root is 57. Right? You can try the fourth question yourself, or if you want, I can do it for you. Okay, not a problem. So 825, so you get 2 and this 8 is alone. So you can do it like this. So take pairs of 2 and 5 as 25, and take this 8 as a single digit. 2 times 2 is 4, right? 425. So 2 times 2 plus 2 is 4. So what should we place over here so that it becomes just less than 425? So if you, it is 48 times 8 is 384. So if it will be 41. If you subtract 384, 425 is 41. So 41 should be subtracted, and the square root is 28. So if so 41 should be subtracted, and the square root is 28. That's the answer for this question. Let's move on to a next question. Now, the same logic holds when you, how much you should add it. So I pick up a question which is a 2-digit number, and I pick up a question which is a 3-digit number. So I pick up this question and I pick up this question. Okay. So 1750, I take this one and this one. Okay. So 1744 times 4 is 16. 1, you subtract it, 150. 4 times 4 is 81. 8. Now, if I put 2 and multiply it by 2, it becomes 164. So I'm just exceeding 150. So how much I need more? I need 14 more. So I need 14 more so that it becomes a perfect square number, and the square root is 42. This is the answer. The square root is 42 and I need 14 more to complete the square root. So I take a single digit, 3-digit number because the number of digits are odd, and this will help you in solving the other two questions. So 525, let's take this. So you take 25 and 5. 2 times 2 is 4. 125. 2 times 2 is 4. So you take 42. 43 times 3 is 129, just exceeds 125. So by exceeds 125 by how much? 4. So which means I need 4 more. And what is the square root then? The square root is 23. Right? So I request you to try the other two questions. Okay. And then I move on to some application-based questions of square and square roots. A gardener has 1,000 plants. He wants to plant these in such a way that the number of rows and number of columns remain same. Find the minimum number of plants he needs more for this, which means what must be added to 1,000 to make it a perfect square number. Okay. So take pairs of 0 and 10. So 3 3s are 9. 3 plus 3 is 6. 1 0 0. Now how much more he needed? So which means I have to find a number here. So that multiplied by that 6 and followed by that digit multiplied by that digit just exceeds 100. So if you see 62 times 2 is 124. So 124 exceeds 100 by how much? It just exceeds by 124 exceeds 100 by 24, which means if you'd have had 24 more plants, then he would have got the number of rows and columns to be same. So he needs how much? He needs 24 more plants. That's the answer for this question. Okay, he wants to plant this. So in the exam, what you can do is you can try like this, and you can say that 62 times 2 is 124. It just exceeds 100. Now you should not place 124 below over here. You just have to write that 62 times 2 is 124. Now this exceeds 100 by 24. So by how much? It exceeds 100 by 24. So this way you can apply these in these questions as well. So you will not write 164 over here. It's just for understanding purposes. You would write it as a separate step in the actual exam. So 164 minus 150 is 14. Okay. Similarly for the other question. The last question in this series is, there are 500 children in a school. For a PT drill, they have to stand out in such a manner the number of rows is equal to number of columns. How many children would be left out in this arrangement? Which means what must be subtracted 500 to get a perfect square? So 500, you take 00 and a single pair. 2 times 2 is 4. 100. 2 times 2 is 4. So 42 times 2 is 84. So if you're seeing that if it would have been 16 less, then I would have got a perfect square number. So how many children will be left out? How many children will be left out? 16 children will be left out. So when it's a question of left out, that means how much should be subtracted from that number to get a perfect square. In the previous question, how much he needs more, which means what must be added to get a perfect square. So in this question, the answer for this question is I need 16 children must be left out and in this arrangement. Okay. Thank you so much. These are some of the sample questions for square and square roots. All the questions of square and square roots are based on these types only. Right. Only thing is you need to have the fundamentals very clear while doing the questions. So before doing the questions, ensure that your fundamentals are clear and you follow all the steps in doing the questions in the right way. Thank you. Happy learning from VMC. Thank you. Wonderful teaching you.